Okay, good evening, everyone. Assalamu alaikum, dear brothers and sisters. Today, inshallah, our second session in the facilities and the process in the oil and gas course, introduction course. Today, we will study some topics about the upstream field mainly. We will speak in details about the upstream today. As we studied last time, we have three main sectors: upstream, midstream, and downstream. Today we will start with the upstream. Okay, we will start with the exploration, then we'll speak about production, and we'll speak about the type of production wells or platforms, which is onshore or offshore. So today's session is so easy. We'll speak about the upstream sector. In the upstream sector, we have exploration, we have production. In the production field, we have onshore and we have offshore. This is the agenda of today's session. Let's speak in details. Upstream, midstream, and downstream. If you follow me in the last lecture, we spoke about the upstream and the difference between it and upstream, midstream, and downstream. In the upstream sector, you have to know that it's mainly for oil and gas exploration and production. The mainly point in upstream is oil and gas exploration and production. However, for midstream sector, the sector in the middle, this will speak about the transportation and storage. Transportation and storage. The last sector, which is downstream sector, speaks about product preparation and usage. Product preparation and usage and refinery or refining or manufacturing or processing or the industry itself. So the last section downstream is refining and distribution for human usage. All right. So the upstream, which we'll focus today, as I told, it has exploration and production. The production and exploration, the people, they can explore the oil or gas on land or on the sea. If they are exploring the gas and oil on the land, they call it onshore. They call it onshore. So if they explore or drilling the gas and oil on the sea, they call it offshore. They call it what? Offshore. So the offshore on the sea, the drilling, the processing of exploration, everything will be done on the sea. However, if it is on the land, so they will mention the terminology onshore. Let's speak on details. This is another photo of the upstream, midstream, downstream difference. I am repeating again so that you will remember this difference, comparison between upstream, midstream, downstream. Upstream oil and gas production exploration, midstream transportation and storage, downstream usage and refining. Again, upstream, midstream, downstream. I'm repeating myself so that everyone will remember the difference. In upstream, we will speak today about the offshore platform and the onshore platform. Offshore, as I said, it is on the sea. Offshore, on the sea, on the sea. The onshore, on the land. Onshore, on the land. So let's have some quick video. It will give you an idea about what I need to say about upstream, midstream, and downstream in oil and gas.
This is the Earth. It's really, really big. It has a total circumference of 40,000 kilometers at the equator, and a surface area of 510 million kilometers squared. And the vast majority of petroleum is found underground. So how on earth do we find it in order to extract it? Geologists can use a variety of different methods to locate oil even when it resides deep beneath the Earth's surface. The most common method of locating oil is via seismic survey. Essentially, geologists use a variety of different tools to emit sound waves, which then delve into the Earth's crust, some of which bounce back to the surface. A computer can then interpret these sound waves and create a detailed three-dimensional image of the various geological formations beneath the surface, thus providing the approximate location and amount of oil in any given oil reservoir. If the oil is worth extracting, we then go on to the next stage of the petroleum industry, drilling. Before the oil can be extracted from the reservoir, a well must first be drilled. This well is created during the second stage of the petroleum industry, drilling. In order to carry out drilling operations, a temporary drilling rig is...
So look to this screen, look to this drilling machine. It is on the land, right? It is on the land, so it is onshore. It is onshore drilling platform or onshore drilling facility. If it is on the land, it is onshore. All right, let's continue the video.
Constructed. The large derrick allows for a pulley system that can support a long drill pipe attached to the drill bit. A turntable turns the Kelly, which is attached to the drill pipe, to allow the drill bit to drill. As the drill bit plunges deep underground, drilling fluid is pumped down through the drill pipe to wash the rock cuttings out. The resulting mud returns to the surface and passes through a shale shaker, which removes any unwanted solids from the mud. The mud is then poured into a tank, where it is then used as drilling fluid to remove further rock cuttings. Once the well has been drilled to sufficient depth, the walls are reinforced with concrete and steel casing, and then the drilling rig is deconstructed. The next stage of the petroleum industry is production. In this stage, the oil is extracted from the reservoir. This is done with an oil rig. The rig's size and shape depend on...
So now I am still in the first section or sector, which is upstream. Please focus on this one. Alert this one, because the next step now is a video will illustrate the next step, which is downstream. Then the last step, it is the next step is midstream. Then the last step is downstream. So now we are in upstream, which is offshore. This is offshore because on the land, the drilling unit is now explored the oil and start to produce oil. Now we start to produce oil from this drilling machine or drilling well. It will go to the next sector, which is midstream. Remember this. Then we will go to the downstream.
Where the oil reservoir is located. In this case, a pump jack is used. A motor turns two crank rods aided by counterweights, which are attached to a pitman arm, which is in turn attached to one end of what is known as the walking beam. The beam is centered on a pivotal point, and the circular momentum of the crank rods force it to rotate back and forth as it is pulled upon by the pitman arm. Attached to the opposite end of the beam is the horse's head, and attached to that is the bridle. As the head travels up and down with the movement of the walking beam, it pulls on the bridle, which is attached to a polished rod. The rod is attached to another rod known as the sucker rod, which extends all the way down into the oil reservoir. At the end of the sucker rod are two valves, the traveling valve and the standing valve. These valves pump the oil up out of the ground as they move up and down with the momentum of the sucker rod. Once the oil is drawn to the surface, it then travels along a small pipeline to a collection plant. This is the end of the third stage of the petroleum industry. From the collection plant, the oil must be transported to a...
So, listen, he said the oil must be transported. Now we are in transportation sector. Transportation, now we transfer to the next, which is midstream. We'll finish the upstream, we'll finish the exploration, we'll finish the production. They produce the oil now. They now need to start to transport the oil. So the transportation is another sector, which is midstream. This is midstream. Look to this screen, to the video now.
refinery.
Midstream.
The fourth stage of the petroleum industry is transportation. In this stage, the petroleum is transported from the production site. This can be done in several ways, by road, rail, sea, or pipeline. Pipelines can be thousands of meters long and are typically made from steel with an average diameter of anywhere between 10 to 120 centimeters. The oil is kept in a constant motion by regular pump stations along the pipeline and flows on average at speeds of up to 6 meters a second. The oil's final destination is the refinery, where the last stage of the petroleum industry takes place.
So now we are going to the refinery. As he said in the video, the last stage of the oil and gas extraction and production. So the last stage is refining. Refining is downstream. Refining is downstream. So this is the third sector. We start with upstream, production, exploration. Then we go to the midstream, which is transportation through this huge pipeline that you see in the video. Huge pipeline. This is midstream, including the pump station that need to pumping the oil to the destination. What is the destination? Is refining. Why you need to refine? Because you need to produce some product. You need to have gasoline, you need to have benzene, you need to have kerosene, you need to have a lot of other products useful for our life, for our cars, for instance, to use gasoline or diesel or cooker. So all of this kind of products, it's being produced in the downstream sector, which is we are going now to see in the video. This downstream video is refining and industry and distribution as well.
The last stage of the petroleum industry is refining. Petroleum essentially is useless in its natural state. What's valuable and useful are the various components that make it up. These components all have different molecular weights and therefore have different boiling points. Petroleum companies take advantage of these different boiling points and use them in order to separate the different components. In order to do this, the petroleum is first heated to temperatures as high as 600 degrees Celsius by pumping it through a furnace. The resulting petroleum gas is then piped into what is known as a fractioning tower, or distillation column. As the gas rises up through the tower, different components condense at different heights. A series of bubble caps then prevent the oil from falling down once it condenses. The petroleum is then pumped out through pipes for further refining, such as the removal of sulfur in desulfurization units. Sometimes the heavier elements of petroleum are broken down into lighter, more useful components, using a coker or hydrocracker. The major products resulting from petroleum refining are liquid petroleum gas, gasoline, naphtha, kerosene, diesel fuels, fuel oils, lubricating oils, paraffin wax, bitumen, and petroleum coke. These products are then used in our everyday lives, such as powering our cars. Petroleum is a non-renewable resource, and so it will not last forever. It is estimated that the Earth...
So this is like small video to explain about the difference between the upstream, which is mainly production exploration. Now we understand. Midstream is for transportation, and downstream for refining and distribution. Now we will speak about the upstream more details. Now we will go back to the upstream sector for more details explanation. As I said, the upstream, it has exploration and production. In the exploration field, the people in the past, they use, some simple features so that they can know there is oil in this area or not. They can notice some tar seeps or some bookmarks from the gases in certain area, in certain location. So they, in the past, they notice there is oil there or the gas there, so they start exploration. This is very old method. However, nowadays, the people with the new technology, they use something more advanced called Pacific seismic, or reflective seismic. What kind of this one? It is like sounds of machines. They produce signals. Let's have to the next photo. It will give you more details about this seismic. This is like a source of sound or signals. They will produce this through air guns, and it will directly go to the deep area of the land or underneath the water for the seabed. Then, if it reflects again the sound waves, these sound waves or reflected sound waves will be transferred to 3D images. And this 3D image will give the people, the journalists, and all the people working in this field, the idea about the condition of this area and the condition of the gases and oil and amount of this gas and the possibility to explore in this area or not. So this is a new technology. They are using this seismic source to have some signals reflected from the seismic source. Then they will transfer this to 3D images. They can then know if there is any gas or oil in this location before they start the exploration. All right. Why they need to do so? Because the exploration actually it costs a lot of money. Typically for offshore oil, it costs about $30 million. So this is really huge cost. Some other leases for the rig typically about $200,000. It is for average to $700,000 per day. So this is too much cost. So this is actually they need to lower this cost as much as they can, but that mainly that's what exploration. Always the exploration is cost them a lot of money. That's why we know they need to do many times some analysis models of some good exploration data so that they can know exactly if there is any oil and gas in this area or not. For exploration, as I said, we have production either onshore or offshore. So for production, actually, we have many types of facilities or typical oil and gas production facilities. We have, as I said, we have onshore, as it's shown in this photo. First one is onshore. It is on the land, so it is onshore facility for production. However, the others are offshore. from 2 to 7 are offshore platforms. And we have from offshore platforms many types. For example, the second one is a fixed offshore platform. Number 3 is called offshore fixed self-contained platform. Number 4 called offshore self-contained concrete gravity platform. Number 5 called floating offshore, which is require some mooring, and this is more flexible for movement from one location to another. Number 6 is storage, shuttle or tanker. Number 7 is offshore floating tension leg platform. And then number 8 is the subsea manifolds. Subsea manifolds. This is mainly the common oil and gas production facilities, either onshore or offshore. This is also a simple diagram of the processing systems in the most of production facilities. In the first diagram here, you will find this production wellheads. This kind of symbols, it is valve. Let me illustrate it by annotation so that you will understand where I'm speaking. So here, this illustration is a valve, open or closed valve. It means this is a group of valves. Valve, what I mean by valve is to open or close the flow. If it is open, the flow will pass. If it is closed, the flow will stop. Like the same valve in your home house, in your kitchen, or in your bathroom, or in toilet. When you are opening, the water will flow. If you close it, the water will stop. This is the same methodology. This is the symbol of the valve. So in the production area, the first wellhead, a lot of group of valve manifolds. They call it manifold. Why manifold? Because there are groups of valve. They call it manifold for testing and production. Then the second stage in this production facility, they will go with some separation to separate the produced oil from unwanted material like water or gases, So there is some separator to separate the oil from water or from gases. So the gases, they go to this gas compression. This is gas compression from high pressure to medium pressure to other pressure, and for water to go to the next step. And also we'll have some symbology about the pump, like water injection pump and gas compression injection system. So this is typically the area or the plot diagram or flow diagram of the production facility, starting from production wellhead, testing manifold, gas compression, metering and storage, and then exportation or export. All right. So next step or next slide, speak more details a little bit about some production. Then also, as I told, there is something called gas oil separation, which means GOSP. It is very common in the production in the upstream area. In the upstream field, you will find a lot of terminology called JOSP or JOSP, GOSP. This is very common small facility like this, what you can see in the screen down. This means GOSP is gas oil separation production. So this is to separate the gas and oil from what? From what? To separate the gas and oil from each other. So you need to separate gas from oil. So you will go to this GOSP, gas oil operation, gas oil separation plant, to separate the oil from the gases. This is again a big picture of the GOSP to separate gas from oil. And actually, this is mainly in the gas processing plant, and this is the oil processing plant. You in the gas, it's go to the gas processing plant for further transport, for further processing, and the oil go to the oil processing plant for further processing. So the oil will be then immediately go to the oil refinery because it is pure oil, and the gas will go to the gas distribution normally. So the gas and oil are now separated. The oil is going to the oil refinery and gas going to the gas distribution. And here, all this is onshore drilling well, and this is on the land, so it is onshore. If it is on the land, so it is onshore as we described. Okay, now in the production, as I said, we have onshore and we have offshore. The onshore, as I said, on the land, so any manifold or any facility or any area or any oil being explored on the land, they put the facility on the land, they put the rig on the land, they start the exploration and production on the land. So they call it what? They call it onshore. They call it onshore because they started on the land. And this is all kind of oil rig. You see here, let me also have annotation to be more clear. You see, this is oil rig. This is oil rig. This is oil rig, and this is oil produced well here. This is well. So this oil rig and this is oil rig, all of them are on onshore. All of them are on onshore. So they are starting to drilling, and here, underneath the area of the land, there is three colors: gases in the top, oil in the middle, water in the bottom. So you will imagine now there is a lot of mixing between gas, oil, and water. There is a mixture between gas, oil, and water. And now, what you need? You need water? No. You need gas? Yes, I need gas. You need oil? Yes, I need oil. So what you need to do next? To separate, to make a separation from water, from oil, and from the gas. So you separate the water first from the oil and gas, first step. Second, you will have a mixture between gas and oil. So you will go to the GOSP, which is gas oil separation plant, as I explained in the previous lecture. This is all in the onshore. However, if the plant and the rig and the oil being explored on the sea, then you will go to the sea, then you call it offshore. What you call it? Offshore. If it is on the sea, you will call it offshore. Then you will start with the same to explore the oil and gas. You will also remove the water. Then you will also again go to the GOSP, which gas oil separation plant. Now let's have some idea about the onshore plant. Onshore like this. This is the onshore drilling unit. Onshore drilling unit. It is onshore, means it is on the land. We are seeing now land. So it is on the land or onshore drilling unit. So actually, this onshore production is economically viable from few dozen barrels of oil a day and upward. The oil and gas actually is produced from several millions wells worldwide. So actually, the gas networking, gathering, can become very large. The production from thousands of wells several hundred miles apart, feeding through a gathering network into a processing plant. So this picture that you can see on the right screen, it shows a well equipped with a sucker rod pump. There is pump there, and it's called donkey pump, often associated with onshore oil production. So this is onshore oil production. So in some area or unconventional area, that is, you will find some very heavy crude and tar sands. This is very heavy, so it's not easy to explore or extract heavy crude and tar sands. So it's become economically more higher in cost. So it will cause the people and the drilling companies more prices to extrude or to extract the heavy crude. Because what? Because the heavy crude is heavy in its material. It's not light, it's not sweet, so it is very heavy. It requires to be extracted a lot of heating to be heated, so that they can extract the heavy crude. The same for the tar sands have lost their volatile component and are strip-minded or can be extracted with steam. They can use steam as well to extract the tar sands. So then, actually, a lot of methods they use it, and this is actually depend on the hydrocarbon component on the crude oil. So in this also photo, it shows you the onshore plant, starting with the onshore rig. Here's the onshore rig. This is the platform of onshore rig on the land, so it is onshore. Then after they produce the oil, they go to the midstream area for what? For GOSP, the gas oil separation plant. This is gas oil separation plant. Then they go to the gases after the separation to go to the gas compressor. And this gas compressor is then transported to the gas turbine, for example, or gas treatment. So this gas treatment is the last destination for the gas after separation from oil. Okay, what about offshore? As I spoke, we have onshore, then we have offshore. The offshore is actually any facility of oil and gas facility which is on the sea, not on the land. It is on the sea. So we have very different platform and very different area of platforms or common offshore structure. The first type is shallow water complex. If you have a shallow water area, then you will use this kind of structure of platform, structure in the shallow water area. If you have more deeper water, you use some other type of structure called gravity base. This kind of structure. This is mainly fixed structure platform. It is fixed, and the end of the storage oil have the shape of a skirt, as you see here, which rests on the bottom of the sea. This actually not in the shallow water. It's more deeper. It can reach to 500-meter depth. 500-meter depth. There is other also type of platform. It's called complaint towers. It's mainly like the fixed type of platform, but they have some foundation, that's why they call it complaint towers. They have some foundation of concrete foundation. So this is to extend upward the platform. But this kind of tower is flexible actually because they have some rigid legs of fixed platform. So let's have some photo about this complaint tower. This is a complaint tower. It's actually going more deeper than the fixed platform. The fixed platform can reach up to 500-meter depth. However, the complaint tower is going more deeper, more depth inside the water. If the area or if the sea is become more deep, then you need to do or to go with not fixed platform, you need to go with floating production. This floating production is not a fixed, it can be float, so it will require deep water. What the common terminology of this floating production, they call it FPSO. This is very common in offshore. They call it what? FPSO. Floating production, storage, and offloading. Again, floating production, storage, and offloading. As I said, the main advantage of this floating unit or floating structure, because it will be standalone. Standalone structures that doesn't need really any external infrastructure like pipeline or storage. It is a standalone. And hence the crude oil is then offloaded to a shelter tanker. There is a tanker here, and this shelter tanker can offload or transport the crude oil to another area or another day. Depend on the production, definitely. These FPSOs actually currently produce around 10,000 to 200,000 barrels per day. Barrels is the unit of the volume of the oil, barrels. So they can produce up to 200,000 barrels per day. As I said, this is typically a tanker type, and they can actually, due to the increasing of the sea depths. So remember that if the increasing of the sea depths, it is become more deeper, then it is better to use a floating type platform for the offshore wells. Here, this is underneath the floating rig. Here, the turret has wire rope and chain connection to several anchors. Here, this is actually allow positioning, dynamic positioning and mooring. They can have some dynamic position and some dynamic mooring. They can be flexible. It can move and rotate. This allow movement and the rotation of this FPSU. So imagine this structure is underneath this huge FPSO tanker. So this FPSO tanker, underneath there is this kind of mooring and dynamic positioning. For what? For easy movement and turning and relocation as well to another area or another location. We have also another type of platform. They call it the tension leg platform. This is actually reached to the depths about 2,000 meters. 2,000 meters, the depth of the seabed under the sea level. So the depth of the sea here is reached to 2,000 meters, 2 kilometers actually. It is very deep. So they use this kind of structure in the deep water, very deep water. They call it tension leg platform. As I see here, as you can see here, this consists of structure vertical tendons, this one, which connected to the sea floor. You see here, it's connected to the sea floor here by biosecure templates. So this structure actually is held by a fixed position. It's held by a fixed position by tension tendons. That's why they call it tension leg platform. The other type, they call it semi-submersible platform. This kind of the platform, offshore platform, is actually similar design, but without what? Without mooring. This permits more lateral and vertical motion. So they can move vertical, they can move lateral as well. So they can have this kind of flexibility to go up and down, depends on what? Depends on the sea current and the winds. So they can go up and down, and depends on the well also. If the well is required to be allocated ups and downs, they can have this kind of flexibility. The other type is called spar. This is spar platform. This actually consists of single tall floating cylinder, and supporting actually with fixed deck, and this cylinder doesn't extend all the way to the seabed. So this actually also required in the deep water. It reached to the 3,000 meter depth of water. The other platforms or not platform, other facility or systems in the offshore, we call it subsea production systems. These subsea production systems are mainly some, if you find some wells located on the seafloor, they are opposite to the surface. So in the floating production system, when we need to extract the petrol as a seabed, then we need to have many production systems on the subsea. And actually, the transportation purpose, if you want to extract oil and you want to transport to another location, you have to have some undersea pipeline and risers. This is the undersea pipeline. Undersea pipeline, it is undersea pipeline for what? For gas transportation, to transport gas from location to another location. So this is actually gives some flexibility to the system so that when the platform it is on the sea, they have to have some other subsea system which is consist of pipeline, as you see here, and structured, and this is really connected together to transport these gases, extracted gases, from one platform to another, or from one platform to another service or another facility or another plant for more processing. For more processing. This is some comparison between the different type of the offshore platform. Fixed platform, as you see here, it is in the shallow water mainly. So the depth of water here is not very deep. If you go deeper, you need to have different type of platform offshore. So if you go deeper with the water, you need to have this kind of complaint tower first. Then if you go deeper, you will use tension leg platform. If you go more deeper, you go many tension leg platform, like this kind of type. Another photo also, for the shallow water, you use fixed platform. It reach maybe up to 300 meters. If you go deeper, you can use this kind of tension leg platform. It reach up to it reach up to 1,200 meters. It can reach up to 2,000 also. Then if you go deeper, you can use floating FPSO, the floating production storage facility of loading. This one tanker actually or vessel, and this is floating, it is floats on the sea, and this is connected with a subsea system up to the seabed, and this can reach up to 2,000 actually meter. This is more deeper than the tension leg. Then if you go more deeper with seabed, you will use semi-submersible platform. This can reach up to 2,000 meters actually. It can reach also up to 3,000 meters, the semi-submersible platform. So deep water also, for the deep water, you can use a spar platform. As I said, you can use floating. This is a floating, as I said, floating production system. You can use floating FPSO with tanker, with a shuttle tanker. You have shuttle tanker, we have FPSO, floating production storage and offloading. You can use this more in more deep water. Let's see one video can explain more details about this one.
Drilling rigs like these bore or drill holes into the earth. They work both on land and offshore. Some are big and some are relatively small. Big rigs drill very deep holes, 20,000 feet, 7,000 meters or more. Small rigs may only drill to a few thousand feet or meters. People in the oil industry group rigs into 6 basic types: land, jackup, platform, submersible, semi-submersible, and drill ship. A land rig drills on dry land. They're the most common rig. Light-duty rigs drill holes from about 3,000 to 5,000 feet deep, or 1,000 to 1,500 meters. Medium-duty rigs drill to depths ranging from about 4,000 to 10,000 feet, or 1,200 to 3,000 meters. Heavy-duty rigs drill holes from about 12,000 to 16,000 feet deep, or 3,500 to 5,000 meters. Ultra-heavy-duty rigs drill holes from about 18,000 to 25,000 feet or more, 5,500 to 7,500 meters or more. Crew members can move land rigs on trucks, tractors, trailers, barges, helicopters, heavy rolling gear, skids, and in rare cases, on specialized air pressurized equipment. Small, light-duty rigs are pretty simple to move. Ultra-heavy land rigs can be difficult to move. A jackup rig drills offshore wells. It has legs that support a deck and hull. When positioned over the drilling site, the bottom of the legs rest on the seafloor. Jackup rigs can drill in water depths ranging from a few feet or meters up to more than 400 feet, over 120 meters. Boats tow a jackup rig to a location with its legs up. Once the rig-up crew gets the legs firmly positioned on the bottom of the ocean, they can adjust and level the deck and hull height. A platform rig is an immobile offshore structure. That is, once built, it never moves from the drill site. Companies drill several wells from the platform. Platform rigs can be tender-assisted rig. The tender floats next to the rigid platform, which is firmly pinned to the seafloor. Many platform rigs do not have a tender. They are so large that they are self-contained. Big platform rigs include the steel jacket platform, the caisson type, and the concrete gravity type. In deep water, rig builders have to make platforms that yield to water and wind movements. 2 compliant platform rigs are the guide tower and the tension leg. A submersible rig rests on the seafloor when it is drilling. Workers flood compartments that cause the rig to submerge and rest on the bottom. When ready to move, workers remove the water from the compartments. This makes the rig float. Boats can then tow the rig to the next site. Rig builders design submersibles to drill in shallow water and in water up to about 175 feet deep, a little over 50 meters. Submersible drilling rigs include the posted barge submersible, bottle-type submersible, and the Arctic submersible. A semi-submersible rig is a floating offshore drilling rig. It has pontoons and columns. When flooded with water, the pontoons cause the unit to partially submerge to a predetermined depth. The working equipment is assembled on deck. On the drill site, workers can either anchor the rig to the seafloor or use a system of thrusters and positioners to keep the rig over the hole. Here, they have it anchored. Crew members mount the wellhead and blowout preventers on the ocean floor. Special hollow pipe called riser pipe connects the top of the blowout preventer to the rig. In some cases, the crew uses thrusters to keep the rig over the hole. Called dynamic positioning, the thrusters, which are connected to an onboard computer, keep the rig in position. Some dynamically positioned semi-submersibles can drill in water depths of more than 7,500 feet, or over 2,200 meters. When keeping a rig over the hole, drilling crews use the term on station. Here's a semi-submersible rig loaded on a special carrier. The carrier vessel is moving the rig a far distance over the ocean. For shorter moves, the rig owner tows the rig to the drill site. Or some semi-submersibles are self-propelled.
So this is actually very useful video I prepared for you so that you can really understand the different type of the offshore platforms in different.
آبار النفط. الجزء الأول مقدمة لأنواع أبراج الحفر والمركبات الأساسية لخط أنابيب.
Need to close this one. So, dear brothers and sisters, I finish my session today. So this is like very introduction to the upstream mainly. As I said, the upstream is mainly exploration and production, and we explain the exploration and production, and we go through the production for onshore and offshore platforms and what type of offshore platforms. Next session, which will be after tomorrow, we'll speak about the wells and the type of wells and how the wells will operate and how the drilling actually will operate. So please let me know if you have any comment or any questions so far in our today lecture. I will open the mic for all of you to allow you to speak.